Hi everyone. By the end of this video, you should be able to complete the square, and we're going to use this to convert from standard to vertex form of quadratics. We're just going to go through an example. I'll give you the steps. We can kind of talk about why. So if I have x squared minus 10x minus 9 equals y, completing the square will help you put that in vertex form, which will help you find the vertex. Now what you need to know about completing the square is it will actually help you factor a polynomial that is unfactorable, and this will work on any polynomial. The first step on completing the square is to move the constant over to the other side. So in this case, in order to move over the minus 9, we're going to add 9 to both sides, because minus 9 and plus 9 cancels, gives you 0. And then we have x squared minus 10x. And I'm going to leave a space here for a reason, which I'll talk about in a second, equals y plus 9. So just move that constant over. That's your first step. Okay, the second step is you want to make sure the coefficient on the squared term is a 1. Which in this case, since it's just x squared, it already is. But in the next case, you might see an example where it's not. And here's the complete the square step. What you're going to do, and I'm not really explaining why right now, but I'm just going to tell you how to do it, is to divide the middle term by 2, which if you divide negative 10 by 2, you get negative 5. Then you're going to take that term and square it. So negative 5 squared. And you're going to take that square term, which we positive 25, and add 25 here. Okay, the most important thing to remember is you can't just change an equation by adding 25. If you're going to do something to one side of the equation, you have to do the same thing the other to keep it balanced. Otherwise, you're changing what the equation's asking. But if you add 25 to both sides, you're going to keep it balanced, because really, if you add 25 to both sides and you solve, and you subtract 25, right, you get the same equation as before. So this is the same equation as long as you do add the 25 to both sides. Okay, so why did I do this though? Like, what did I really make happen here? The goal of completing the square, like I said, is to take something that might not be factorable and make it factorable. So what I actually did by dividing by 2 and squaring it is I made this a perfect square trinomial, which I'm going to factor first so you can understand why that is. Okay, so now we create something that's factorable. We're going to factor this polynomial. So I set up my parentheses. What multiplies by x squared would be x and x. What multiplies with 25 and adds to negative 10 would be negative 5 and negative 5. And then I'm just going to clean up the side here. So 9 plus 25 would be y plus 34. Now, since I have two x minus 5s here, or x minus 5 multiplied 2 times, that can be written as x minus 5 squared equals y plus 34. Okay, so going back to y, though. As you can see, when I factored, this is a perfect square trinomial, but why did I do that? The first thing that's really important to know about algebra, I'm going to write this off the side, but you don't have to write it, is anytime you have an equation, let's say it's 3x plus 1 equals 7 even, any equation, you can add or subtract something for, as long as you do it to both sides, it's not going to unbalance the equation, right? So I could subtract 1 from both sides, and I still have the same equation. Okay, it's just a simplified version. Okay, at the same time, I could also add 1 to both sides. Okay, as long as I do it to both sides, it would keep it balanced. So this would become this equation, which if you subtract 2, would give you the exact same equation that we had before. So you're keeping it balanced as long as you're doing it to both sides. Which, what does that even matter to what I'm talking about right now? The key is to understand, like, I could add this 25 to both sides and it would keep it balanced, but really I could add anything to both sides. So instead of making this a 25, I could have added 100 to both sides. I could have added 7 to both sides, but why 25? And the key is to understand what it did when I added 25 to both sides is the fact that it made this factorable. It made it a perfect square trinomial, so it factors to look like this. A perfect square trinomial always factors to be the same term multiplied 2 times. Okay, so with that said, the reason this is a perfect square trinomial is because I divided this by 2, squared it, made this a perfect square, and also this number, the square root of it times 2 times the square root of this will give you this. So I chose a perfect square trinomial to do what I needed it to do, which was to be factorable, but also, if you look at this over here, if I isolate the y by subtracting 34 from both sides, I get y equals x minus 5 squared minus 34, which is vertex form. And in vertex form, I know the vertex is 5, negative 34. Okay, so what you really need to understand is the completing the square process isn't random, it's strategic. It's strategically helping you factor this expression in a way that's going to give you perfect square trinomial, which also gives you our vertex form, is when you have that binomial repeated. So those are the complete the square steps. That might be a little confusing on why it makes sense. Please ask questions if you have them, but we'll try another one. Okay, just going through the process. The first thing you want to do is you want to isolate the variable terms by moving the constant over. So now you have 2x squared plus 6x, and I'm going to leave a space there because we're going to complete the square, equals y minus 5. Okay, this problem is slightly different than the last problem because, like I said, the coefficient always needs to be a 1, and here it is not. So what can I do to this expression to keep it equivalent? Okay, not get rid of the 2, just make it magically disappear, but also have the coefficient 1, is you can factor out a GCF, which if you do that, the coefficient on the x squared will be a 1. Okay, so I didn't get rid of the 2. I didn't unbalance the equation. I just factored it out. So now you want to complete the square step, where you have the b and square it. So I take half of 3. It's 3 divided by 2. I'm going to leave it as a fraction. It's 3 divided by 2. Again, that's dividing by 2. And then you square it. So what's 3 halves squared? Is 3 halves times 3 halves, which is 9/4. And yes, it is okay to have fractions. Okay. Now, with that said, whatever you do to one side, remember we have to do to the other. So I added 25 to both sides, and then I could do that because it kept the equation balanced. Okay, so I need to add this to the other side as well, but this is a little bit tricky, and this is a step everybody forgets. You're not actually adding just 9/4 to the side. Okay, if you distributed this 2 out, you're actually adding 2 times 9/4 to the left side. And you have to do the exact same thing to the right side. And I'm going to actually write that out without distributing. You have to add 2 times 9/4. Okay, which is, I simplified that. It's 2 over 1 times 9 over 4, which is 18/4. Okay, that's the most commonly forgotten step. So please make a note of that and make sure you do not forget it. And that only happens when you have a GCF here. That didn't happen before because we were just adding 25. So now with that said, because I created a perfect square trinomial, I can factor. Okay, and then I can get something that looks like vertex form. Now, you could factor this with fractions. It's probably going to be ugly to guess and check. And that's a nice thing about perfect square trinomials is they always factor in a pattern. They're always the same 2 binomials, so you can write it squared. And the way we got this, x minus 5 is actually comes from the half of b, was minus 5. And that's how perfect square trinomials will always factor. So if you remember that pattern, you don't have to guess and check. Although if you don't, please do guess and check so you can see that that works. But for now, I'm just going to use the pattern. Okay, these would all be plus signs though, because it has to multiply to be a positive and add to be a positive. So there's no subtraction. So with that said, I have y minus 5. Oof, fractions, yikes. But that's okay. -5 plus 18/4, we can add that together in a moment. The only difference between this one and that last one is you had to factor out GCF. Hopefully that we are seeing the connection between the two. Final step is we wanted to do this to write it in vertex form for this particular kind of problem. So I'm going to move all the constants back to the left here. So this stays the same. And I'm just going to add 5 to both sides and subtract 18/4 from both sides. So I'll add 5, subtract 18/4. We can combine those in a second, and that equals y. Okay, so what's 5 minus 18/4? I'm going to pause the video just to do this real quickly. You can do it on your own paper. It's good practice. Okay, if you added them, you should have got 1/2. You can look at my work up here, which makes the vertex of this -3/2 and 1/2, which is why completing the square is helpful. We don't have to do anything except rewrite it in a different form, aka vertex form, to find the information we need. Okay, so with that said, I'm going to leave this problem for you to complete on your own to practice completing the square. I'm actually going to come back with the answer, so please pause the video. Do not cheat. This is a chance to self-assess. Go. And here's the answer for you to try on your own. I wrote in red the step that most people forget, so see if you remembered or forgot that step. See if you got the same answer as me. Look through my work. And if you have any questions, please feel free to ask. Another important thing is that, again, it's okay to have fractions. That'll happen sometimes. But just don't forget to factor out the GCF, and don't forget to add whatever you're adding to both sides. Otherwise, you will change the equation. Okay? If you have any questions, please ask them. Otherwise, have a good rest of your day.